everyone. I hope you all are practicing questions. Let us for now get at this one. Question क्या कह रहा है? There are two uniform semicircular discs, each of radius r, and they are stuck together to form a disc. ठीक है? Masses of two semicircular parts are given. यहाँ पे दिया हुआ है. We have to calculate moment of inertia of this composite disc about an axis perpendicular to its plane and passing through its center of mass. So first of all, we need to find out where is the center of mass of this composite system. So let's treat this point as the origin. And if you do so, then I mean this is one half disk and this is another half disk. And for half disk, we know that center of mass from this position will lie at a distance of 4r by 3 pi, right? So देखो first इसका center of mass कहाँ होगा 4r by 3 pi, and same will be true for this 4r by 3 pi. So there are two masses m and 3m, and their center of masses are at a distance of 4r by 3 pi and minus 4r by 3 pi. क्योंकि अगर आपने इसको origin माना है, then one direction will act as positive direction, another direction will act as negative direction. ठीक है? So चलो center of mass निकालते हैं. Let's say this is the x axis we are taking. So what will be the value of xcm? That you will be writing as 3m into 4r by 3 pi plus m into minus 4r by 3 pi divided by m plus 3m. Done? So if you just take here 4r by 3 pi common, and then it will become 3m minus m, that is your 2m, divided by 4m. So we will be left with what? We will be left with 2r by 3 pi. And this is positive, right? So center of mass of this composite disc will be somewhere to the right of this center, and this will be somewhere here. So let's say this is the point of center of mass. This is the position of center of mass, which will be at a distance of 2r by 3 pi from this distance. ठीक है? Now let's focus on the question. Question में क्या कह रहा है? We have to calculate moment of inertia around a line passing through center of mass and which is perpendicular to this plane of disc. Okay? So how we will do that? देखो यहाँ पे है हमारा सेंटर ऑफ मास, यहाँ से लाइन पास कर रहा है. वी हैव टू कैलकुलेट मोमेंट ऑफ इनर्शिया अराउंड दिस लाइन. So we can take the help of parallel axis theorem in order to solve this question. और कैसे? देखो इस लाइन के अराउंड we know moment of inertia of this system, right? क्योंकि अगर आप इस लाइन को देखो, then moment of inertia of this disk will be around this line, nothing but mr square by 2. And for this disk, that is mass of 3m disk, half disk, moment of inertia around this line will be 3mr square by 2. So moment of inertia of the whole disk will be sum of these two, क्योंकि moment of inertia is a scalar quantity. We have calculated moment of inertia for one half part, then for another half part we can add it like this. इफ यू आर थिंकिंग कि मैंने यहाँ पे मोमेंट ऑफ इनर्शिया का ये फॉर्मूला कैसे लिखा, तो देखो डिस्क के लिए हमें पता है डिस्क का मोमेंट ऑफ इनर्शिया अराउंड एन एक्सिस पासिंग थ्रू इट्स सेंटर परपेंडिकुलर टू द प्लेन, एंड व्हेन दिस डिस्क इज यूनिफॉर्म, इन दैट केस it is mr square by 2. And I have discussed it in previous videos also that even if you are taking half this, same formula will apply. Why? Because even if half portion you are removing, you are not doing anything to the distribution of mass of the remaining portions. So moment of inertia formula will remain the same. जैसे आप एक whole disk को कितने पार्ट में डिवाइड कर सकते हो? इतने पार्ट में. I mean there can be so many parts, infinite parts there can be, and each part का moment of inertia होगा around an axis passing through this point perpendicular to the plane, and sum of all this moment of inertia is adding up to mr square by 2. So if you say if this has a mass of dm, this has a mass of dm, so each portion, I mean not just this whole, so each portion will contribute to the value of moment of inertia, and each part will have moment of inertia equal to dm into r square by 2. So summation of it will give you the whole value. So I mean even if you are asked to calculate, or whenever you are asked in question to write the moment of inertia of a part of a disk, it will be the same. I mean same formula you will apply with mass different, right? So that is why I've written here. So इस axis के along moment of inertia क्या है, add कर दो, you will be getting 2mr का square. Now let us use parallel axis theorem. Parallel axis theorem हमसे क्या कहता है? So ICM plus this distance, and this is the position of center of mass. So this is the position where 4m mass is concentrated. So ICM plus 4m into this distance ka square, and that will be how much? That is 2r by something we got, right? Yes, 2r by 3 pi. So that is equal to 2r by 3 pi. डन है. इसका स्क्वायर विल बी इक्वल टू आई, वेयर आई इज द मोमेंट ऑफ इनर्शिया अराउंड दिस लाइन. Okay, this is the simple formula, right? So if there is a line passing through center of mass, then and there is another line which is parallel to it, and then there is separation given between these two lines, let's say d, then moment of inertia around this line will be ICM plus MD square. So the same thing I have done here. Different thing is ki I is given, I is known, we can calculate it. ICM we are asked to find out. So ICM का value क्या होगा? I is your how much? 2mr square minus 4m into 4r square by 3 pi. ठीक है. अब देखो इसको आप simply solve कर लो. So if you take here 2 common, you will be left with, आई मीन एक काम करो, 2mr स्क्वायर को कॉमन ले लो. ठीक है. सो 2mr स्क्वायर 1 माइनस दिस इज 8 बाई 3 पाई. डन है. So this will be the answer. Okay, 3 nahi 9 pi square, sorry. This is your 9 pi square because we have to do the square of this thing, right? So this will be your answer. I hope you have understood this question, and I hope every part of it is clear. But if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Bye bye. Take care and keep on solving more number of questions.